Okay, so in our last class, we were discussing about electromagnetic waves and we discussed its properties and all, right? So today we will be discussing about laser. First, I will explain. After that, let's write down. Okay. So laser means light amplification, light amplification by stimulated emission of radiation. So laser stands for light amplification by stimulated emission of radiation. Now, to understand how a laser works, first we have to understand a few concepts or few things or when light interacts with a certain material, the few processes that could occur. We have to know about them. So there are three types of processes. There are three types of processes that could occur when light interacts when light interacts with a medium, with a material medium. So there are three processes. If you look at those three processes, first one, the first process is absorption. The first process is absorption, and the second process is spontaneous emission. Spontaneous emission, and third process, it's stimulated emission. Stimulated emission. So whenever light falls on a certain medium, yeah, I will explain this. After that, I'll give time to write, okay? So there are three possible processes that could occur when light falls on a medium. One of them is absorption, spontaneous emission, and stimulated emission, okay? I will completely go from the first. I'll give you time to note. For now, I will explain these processes. After that, let's note it down, okay? So, let's look what are these three processes. First, let's understand what are these three processes. Absorption means we know that let's write this down. Put down the topic laser, and under that write down the term laser. The term laser is an acronym, is an acronym for light amplification by stimulated emission of radiation. The second point, when light interacts with a material medium, three processes can take place. So these are the three processes that can take place. Noted. Next point, we know how an atom is, right? In the atom, we have the nucleus. Around the nucleus, we have energy levels. As we go far away from the nucleus, the energy of the energy level increases. And we called the first energy level or the least energy level, this as the ground state. This is the ground state. And all the other levels, we call them as excited state. And the final energy level, we call it as the ionization state. Okay, the final is the ionization state. Because if the electron tries to go beyond this, then it is removed from the atom. lowest energy level an electron can occupy is the ground state. Next point, electron will always be in the ground state if it doesn't absorb energy. Electrons will always be in the ground state unless it absorbs energy. If it absorbs energy only, it can get to other levels. So except the first level, all the other levels, we call them as the excited state. All the other levels except the first level is called is called the excited state. Is called the excited state. The final energy level, the final energy level is called the the final energy level is called the uh, ionization state. Once you have noted up this, let me know. Done. Najima and Hana, how about your done? Hana, okay. So now let's discuss about what's absorption. First, absorption. So absorption means now what we are going to do is we are going to excite the electron. So initially the electron is at energy level E1. It is at energy level E1. And by providing some radiation, by radiating some radiation, what we can do is we can excite the electron from this lower level to a higher energy state. But this difference in energy, the energy we supply, has to be equal to the difference in the energy. Now let's say this gap has an energy difference of 100 joules, and I radiate using a photon of 110 joule. Then this electron doesn't get excited because it is not equal to this energy difference. If the energy difference is 100 joule and I provide 100 joules, then it will get excited. If it is less than, obviously it is not going to excited, right? It is not going to get excited. It is not possible. So this condition is very important. That is, the energy we provide, has to match the energy difference between these two levels. Only then this electron is going to get excited, even if it is greater or it is lesser. There is no excitation. Okay, is that idea clear? So this is energy level 1. So this is the ground state. So this is the ground state. And this is going to be the excited state. Okay. So do you get the idea? Yeah. If this energy difference, I mean, this is the ground state and this is the excited state. Now, each and every energy level is going to have a certain energy, right? You might have studied in your chemistry that each and every level has its unique energy. So let's say the difference between these two levels is 100 joule. Then now this is a radiation, right? So radiation will contain photons. Radiation will contain photon. The energy of a photon, if it is 100 joule, if energy of this photon is 100 joule, what can you tell about this electron? Will it get excited or not? It will get excited because both of them are equal. This energy gap and the energy I provide is equal. But if the energy of this photon is 110 joule, then will it get excited? No, it is not going to get excited. What is the reason? Because it is not matching this energy difference. Clear? So shall we write it down? An electron, an electron will be raised, will be raised to excited state, to excited state only if, only if the input quantum of energy, only if the input quantum of energy is equal, is equal to the difference of quantum of energy exactly matches the energy difference between the levels, and matches the energy difference, energy difference between the energy levels, between the energy levels. Are you all clear with that idea? What's mentioned in that note? Done. Next we have spontaneous emission. The second one is spontaneous emission. Spontaneous emission. In spontaneous emission, it is the opposite. Now, this is gaining energy to get excited. In spontaneous emission, it loses energy to fall back to ground state. So, initially, the electron is already in the excited state and it falls back to the ground state. So, it is in the excited state E1 and falls to, sorry, it is in the excited state E2 and falls to E1. When it is falling down or when it is uh, falling to ground state, it will release energy. It will release energy in terms of photons. And this photons is going to have energy equal to E2 minus E1. Okay, so this is a spontaneous process. This will happen automatically. We do not need to supply any energy. Okay, so below this we can write down, when an electron is excited, when an electron is excited, its tendency is to fall back to ground state. Tendency is to fall back to ground state. When electron falls back to ground state, when electron falls back to ground state from excited state, it releases energy. It releases energy in the form of photon. In the form of a photon. Okay. Is that idea clear? What's spontaneous emission? Once you have noted down, let me know. So below this, let's write a few note. Did this process require any energy? Did we provide any external energy? No, right? For absorption, we provided external energy, but for spontaneous emission, we do not provide any external energy. So the process do not require any external energy source. Do not require any external energy source. Second, Emission of light. Emission of light in ordinary sources. In ordinary sources is due to this. Is due to this process. Is due to this process. So the light bulbs all around us, this uses this process. We are exciting an electron. We are exciting an electron from ground state to excited state, and we let it to fall back. When it falls back, it releases photons. So these photons that will give us light. Okay, if this photon is within the range of visible light, then it is visible light. Okay, it will give you visible light. So ordinary source uses this process to give off light. Note number 3, this emission doesn't have a certain direction. It will emit in every direction. The radiation is emitted in all directions. Therefore, we call this, incoherent. Incoherent. Therefore, we call this one as incoherent. Done, and I will clear up to this. Najima, how about you? Clear and done? So these two processes, this is not much useful for laser. Okay. The third process, incoherent. Incoherent means it is not in a direction, not in one direction. There is no order. It is in every direction. Okay. So that is incoherent. If all of them are syncing together and all of them are in the same order like this, then it is coherent. So this is incoherent, this is coherent. So the third process, it's stimulated emission. So second, we discussed about spontaneous emission. Now let us look at stimulated emission, third. So in stimulated emission, in an atom, in a single atom, when we take a system, you won't have a single atom, right? You will have a lot of atoms. In a material, you're going to have a lot of atoms. So in one atom, it will get excited. Similarly, in all the other atoms also, the electron will get excited. Now, let's consider in an atom, we have an excited electron. And in another atom, also we have an excited electron. So this is already excited. And here also we have an excited electron. So both of them are in the same energy level. Now, an interesting phenomena is going to occur. That is, when this undergoes a spontaneous emission, a photon is released. A photon is released. And this photon passes uh, this atom, passes this atom. When this is passing this atom, look, this photon, and if this electron falls down and it releases a photon, both of them are identical. So what this photon does is it is going to stimulate this to release the photon. So when this is passing side by, when this is passing close by, what this does is it stimulates this to uh, undergo emission. So now this will release a photon, another photon, and these two photons are in the same phase. That means they are similar. So both of them become coherent. Is that idea clear? So just like when someone is studying and your friend goes to play, then you also feel like you also going to want to go to play, right? It is similar. So here, when this electron falls, it releases or emits a photon, and this also has the same energy difference. So what it does is it stimulates the second photon to release a photon. So here, this is an atom. This is one atom, and this is another atom. Okay, in this atom, we already have an excited electron, and here also we have an excited electron. So in this first atom, atom 1, a spontaneous emission occurs. Due to this spontaneous emission, a photon is released. Okay, now this photon will travel, right? When this photon is traveling, it is going through this atom. So in this atom, we have another electron that is excited. So what this photon does is it stimulates this electron to fall down. This stimulates this electron to uh, emit emit another photon. So this is the initial photon. This is the initial photon. Okay, initial, and this is due to stimulation. Stimulated. This photon stimulated this photon to release energy. I mean, this electron to release energy. Is that idea clear? What is stimulated emission? Understood or not?